Hi everyone, it's Mrs. H. Today we're going to talk about synthetic division, which is section 8.4. When we learned long division, I told you that we were going to learn kind of a shortcut, and you were going to hate me for doing the long division out. But it is still important to know. But what I want to start out with is kind of looking at our long division. So this is number 7 from our homework. You can see that there's a whole lot of repetition in this problem. When I do my long division, we kind of do the same algorithm every single step. We're doing a lot of the same stuff. The other thing to kind of highlight here is that we know we start with our x cubed, then we go down to our x squared, then we go down to our x, and it just kind of all iterates from there as we go. Well, what we're going to learn today is synthetic subdivision, which is a shortcut using only the coefficients. This is the setup for this problem. Notice what I did is I took my coefficients. I had a 1 in front of my x cubed, and so I put a 1 here. I had a -1 in front of my x squared, and so I have a -1 in kind of my second spot. A -10 in front of my next term, and so that's my -10 here. And then last we had our constant, which is our +10 and our +10. But you may have noticed that this 3 is different than our x minus 3. What we have to do is we have to take our divisor here and actually set it equal to 0. What is the answer when we set this equal to 0? Well, our root would be 3. Now, this isn't actually a root because we got this remainder in the end. But if we were thinking about this as roots, then our root here would be 3. That goes back to that binomial of x minus 3. All right, so now we have another kind of algorithm for synthetic division, but it is a whole lot quicker. So what we're going to do is we're going to drop down our first term, our 1 here. I'm going to write it again. I'm going to multiply 3 times 1. So I'm kind of pairing those two up. It gets too messy if I draw too many lines. 3 times 1 is going to give me 3, and I'm going to put that next here. Now, over on the left, when we did our long division, we then did minus, 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 as we did our problem out. This time, because we flip-flopped to this x equals 3 as our root, we're going to add. So, -1 plus 3 is going to give me 2, and now I'm going to reiterate that. 3 times 2 gives me 6, -10 plus 6 is going to give me -4. 3 times -4 is -12, which gives us our remainder of -2. Some of these numbers showed up in our original problem if we pay close attention to all of our different steps here. So let's see. What happened is I started with an x cubed, and then I got a minus 3x squared. And then what happened is I got a minus 6x when I went back and multiplied that 4. And then when I multiplied again, I got that plus 12. So you see some of these numbers happening again in our problem. This is just kind of a shortcut. Now, my last thing is I do need the original problem in order to answer this question. I need to know that my purple here was an x cubed. We're dividing out an x, which means I went down by 1 degree. So in my answer here, this is now going to be an x squared, and I'll count down from there. So that will be an x. That's going to be my constant, which means this last one here, sometimes I'll box off, is going to be our remainder. We get the exact same answer as before. I get 1x squared plus 2x minus 4 plus my remainder of -2, which we said last week, I don't care how you write it, if you do the minus there, or if you wrote it as plus negative like that. Same answer, a whole lot less writing stuff down. All right, let's try another problem. And let's see what happens with our synthetic division. All right, so let's try number 2 here. We're going to set up our synthetic division with all of our coefficients. I'm going to write my 2, my -5, -12, 2, and -8. In my box is going to be a +4 here because I am setting that bottom, that divisor, equal to 0. And let's go through our algorithm. Drop down my 2, I multiply, I get 8. Add together, I get 3. Multiply, I get 12. Add together, I get 0. I do have to keep going. I get 0. Add together, I get 2. Multiply, I get 8. Add together, I get 0. Ooh, what happened here? Well, my original problem was an x to the 4th. That means my answer is going to start with an x cubed. And then I have 3x squared. I have no x's. I have a constant of 2. And this remainder means that it divided evenly. All right, we're going to do just 2 more on the front here. And then I think I'll just, we'll do 1 more on the back. These 2 just have kind of special things that you have to pay attention to. All right, number 3, as I'm setting it up, when we did long division, we had a problem like this where we were missing an x cubed and I made you leave space. Well, it's crucial here that you include it when you're setting up your problem. So I have 1x to the 4th. I have no x cubes. You have to include that 0. I have -4x squared, 1, and then 4. Everything else was fine. In my box here is going to be my -2, and I can just go through my algorithm, multiply, add, multiply, add, multiply, add, and multiply, add. This is my remainder. It's always going to be your remainder, that last piece. Let's see what my answer is. I count down by 1, so now I have x cubed. So I have 1x cubed minus 2x squared. I have no x's. I have a constant of 1. And then my remainder, I still want to write over my divisor, so it's over x plus 2. All right, number 4, something else special is happening. What is happening here is, again, you kind of have to set this equal to 0. You cannot just pick that number here, that 2, and flip it to a negative. You have to really set this equal to 0 to give you what that quote-unquote root would be. In other words, your divisor here has to be in x minus c form, where you're subtracting just a number. Well, a binomial of 5x minus 3 is going to give me a positive 3/5 in my box. Let me write everything else down. I have 5, I have -3, I have no x squareds, I have 10 and 2. And then a little bit messier, but you can still multiply. You know how to deal with fractions. All right, so I'm going to multiply 3/5 times 5. That's going to give me 3. Oh, how nice, because multiplying by 0 is just 0. I get another 0, so even nicer. I'll multiply by 10. That's going to be 6. So actually not too bad. All whole numbers here. There's my remainder. I started with an x to the 4th, so I'm going to have 5x to the 3rd, no x squareds, no x's, and my constant is 10, plus my remainder you could write over your original divisor. So I'll write it as over 5x minus 3. You, of course, could write it over x minus 3/5 if we had rewritten it. I don't love doing that. I kind of just like setting it equal to 0 instead. All right, one more problem. Let's do one where we have to work backwards, and then you can try number 1 and number 5 on your own. I will give you a hint on number 5. You don't, actually, never mind. I'm going to let you try number 5. We can look at it at another time. I want to find my value of k so that this is a factor. I'm going to set up my long division. I'm going to have my 2x cubes, my 3x squareds. I'm going to have no x's, and then my constant here is k. And in my box, I'm going to have -2. Now, let's see. I want x plus 2 to divide evenly into my problem. that means that I want to get a 0 here. You can write that 0 in now if you want, or you could write it later. Either way is fine. Let's go through our algorithm. I'll bring down my 2, I'll multiply, I'll add, I'll multiply, I'll add, I'll multiply. And when I multiply here, I want to add these together to get 0. So that is where my equation is coming from that I'm going to solve. Let's see, if k plus -4, which is just k minus 4 equals 0, well, that means k has to be 4. You could go back and check, do your long division out with a 4 there, but I think we all can see that it does work. All right, this is much quicker, very nice, but you do need to be careful of those couple of picky things. So good luck with the problems, and let me know any questions that you have. All right, thanks, everyone.